Hey class, this short lecture is going to be about generics in Java, and then we'll see soon in all of our data structures how we use generics, how queue, stack, those kinds of data structures use generics under the hood. So generics are basically classes that generalize a type away and make it so that the client can implement that class with any underlying class they want. Sounds confusing. But really it's not, it's easier to grasp when you see an example. So say we want a pair of two objects inside of Java, right? We want a pair of any two Java objects. So we could have a pair of integer and natural number, we could have Boolean and double, simple writer and simple reader, literally any pair of two objects. If we wanted to do that traditionally, we'd have to make a new class for every single type of pair, but we don't have to deal with that, right? So what Java offers is something called generics. So I'll go ahead and make a new class called pair. And to make this a generic, all we do is add this caret right here, and then we have just two capital letters for the types, basically. So we're going to have type A and type B, let's say. So we're going to have a pair of type A and B. So now in my actual class, I can say A first item, B second item, right? So these are now actually, this is like a stand-in class name. It's not actually of type, it's not actually a class called A. It's whatever the client decides to create the pair as. So let's say we create a constructor. We don't need the carets there, but then we have to have two inputs, A and B. So then I say this dot first item equals A, and this dot second item equals B. So super basic class. All I'm doing is, holding two items of two different classes, A and B. This can be whatever the client decides. And I made a constructor so that when they create their pair, they have to pass in two items of the correct type, and then I store them. And then I guess I could say public get first item. Alright, this would return A, and I would just return first item, right? Because the return type for this would be A. It's a class. Similarly with B, if I wanted to return the second item, I have to return B, or something of type B, and then I just return my second item. So let's see how the client views this. I have a bunch of natural numbers, some ints and doubles here. I'm going to make some pairs out of them. So I'm going to say pair P1 equals new pair, right? This is how you would normally do it, let's say with non-generics, right? If this was just like a pair I coded for just natural numbers, this will work fine. But you see it's yelling at me. It's telling me that pair is a raw type. So we have to tell it what generic types should be parameterized. So what we do for that is add in this caret, our same brackets that we have over here. And we're going to put in our two types. Natural number 1 and natural number 2 are both natural number types, the interface class. So we're going to put natural number, comma, natural number. These correspond with the A and B parameters up here in the pair. So we want that on both sides, next to both of these pair creations. And there we go. So this is how you create a pair, this generic class that I made. And let's do that again with maybe with primitive types. So let's see what happens if I try to do two doubles, right? So let's say I want to do it from pi. I want to hold pi, which I define up here. I just want to hold 1.0. It actually yells at me. It says I can't do, it says something about dimensions, but the thing that is happening here is that we can't use primitive types in our generic class. What we have to do use the wrapper types for generics. So for double, it's just uppercase D double. And this is the wrapper type for double. Basically, it's a double, but it's a class around it. So it's not the generic type. I'm sorry, it's not the primitive type. We also have the integer class for ints, right? You use this for parseInt. For character, it's capital C character. Similarly for other primitive types, basically just the word with the capital first letter. And that's how you create a generic type with a primitive as input. Like I said, we can mix and match. So if we want a double and a Boolean, I can do this and then pass in T, which I define over here as true. And there we go. So now we have a pair from a double and a Boolean, and these can be in any order, as long as the order here in your actual constructor is correct. So if I were to throw in T pi, it would get angry because it expects this to be of type double and this to be of type pi. So that's the overview for generics.